Again, if you have questions at any point, please just interrupt me, okay? It's not mean. It's just the way that we have to do things. So all of these identities right here, so the quotient identities, reciprocal, and Pythagorean identities, make sure you know these, write them down. You can use like a sheet of paper or whatever for the test. Have these somewhere that you can reference them. Okay. Now, questions like this aren't on the review, and I should have put them on the review. That's my bad. There are questions like this on the test. So it's going to give you like something equals something, and we have to just make these equal each other. We have to prove it to ourselves that these equal each other. Okay, so here, the first thing I'm going to do is you have to choose a side to work on. And obviously, always pick the harder side. This left side is way harder than the right side. The right side, there's not a lot we can do. Like, you could try and start going somewhere, but it's going to be hard to make the right side look like the left side. So here, the first thing I'm going to do is switch everything to sines and cosines. So cotangent is the same as cosine over sine. That sine is going to stay as sine. And then this cotangent, same thing. If I'm switching it to sines and cosines, that's cosine over sine. Tangent is sine over cosine. And then minus that sine squared of theta. And I just kept that equals secant of theta just to show this. So like on the test, these are going to be ones you have to write on a piece of paper and then submit it. So you're just going to have to like take a picture and upload it. But then here, so I can cancel those sines of theta right there. And here I can cancel cosines and I can cancel sines. So on the top, I'm just left with cosine. On the bottom, since everything canceled there, I'm left with 1. And I'm left with 1. That sine squared of theta is still there. So 1 minus sine squared of theta. Now everything's in sines and cosines. I see this sine squared, which makes me think it's probably one of these Pythagorean identities because that's where the squareds come in. And if I look right here, cosine squared of theta equals 1 minus sine squared. So I'm going to replace this with cosine squared. So it's going to be cosine over cosine squared of theta equals secant of theta, which that cosine squared is the same as cosine times cosine. So those cosines cancel, leaving me 1 over cosine, which equals secant of theta. So then we proved that. That's as far as you need to go. So on the test, this is one you're going to have to submit with a paper. Like you're just going to have to take a picture of it. This is what I want to see. Okay, something similar to that. Okay, is there any questions on that one? I'm going to do 3 more of these because these ones, they're kind of hard. And I just want to make sure we get them. Okay, I'm assuming we're okay. So this one, so cosine times cosecant times secant squared minus 1 equals tangent of theta. So the first thing I'm going to do here is this secant squared minus 1. That's the same as tangent squared of theta right here. So if I can change something right at the beginning that is a Pythagorean identity, I'm going to change it. So we can change this to tangent squared minus 1. Or not tangent squared minus 1, just tangent squared of theta. Then I'm going to switch everything to sines and cosines. So this is going to be cosine of theta. And then cosecant is 1 over sine of theta. And then tangent squared is sine squared of theta over cosine squared of theta. So you can square this whole thing, which would just put squareds everywhere there. Okay. Now here, I'm just going to rewrite these, and you don't have to do this step. If you like can tell that, oh, that sign is going to cancel with one of those, leaving me 1 there, that's fine. You don't have to show this step. But I'm just going to rewrite these. So then here I can cancel. It's easy for me to see that those signs are going to cancel and these cosines are going to cancel. So I'm left with just sine over cosine, which does equal tangent. Okay. Is there questions on that one?
So Are you going to give us the equals tangent and it's mostly just a proof?
Yes, yep.
Okay.
I'm going to give you what it equals, and you just have to go through the proof. So you know what you need to get it to, which is helpful. I will give you that equals part.
Okay, thank you.
Yep. Any other questions?
So we're just trying to get it down to its simplest form?
Pretty
Or
much.
like-
You're supposed to prove that like both sides equal each other. So you want to simplify the side that like looks really ugly until you prove to like me and to yourself that it does equal whatever the right side equals.
Okay.
Okay.
On the test, will you be giving us any that don't like equal each other, or
Yeah.
are they all going to equal each other?
They'll all equal each other. Yeah, they'll all equal each other.
Okay.
Will there be some where there's like two messy sides and you have to make them equal each other?
Nope. One will always be like a simple side.
Okay.
It'll be pretty obvious which side to use.
Great.
Okay, let's do another one. So this one right here, we have tangent of theta times cosine of theta plus cotangent of theta. So if you get one that you can multiply, like this right side, I'm not going to do anything with. This is the more simple side. So here, I'm going to start by multiplying this out, like distributing it. So this is going to be tangent times cosine plus tangent times cotangent. Now, once I'm here, I'm going to switch everything to sines and cosines. So tangent is the same as sine over cosine. So that's going to be sine over cosine. That cosine just stays cosine. Tangent, again, is sine over cosine. Cotangent is cosine over sine. And then we can start canceling stuff. So like these cosines there will cancel. These cancel and those cancel. So I'm left with sine of theta. Everything canceled there, so plus 1. And that equals sine of theta plus 1. Sorry, my dog's crying. I don't know if you can hear him. Questions on that one? Okay, let's do one more. This one's probably the ugliest one that I'm doing on here, but so let's try and get this to equal sine squared of theta. This left side is the harder side, so I'm going to start by switching everything to sines and cosines. So tangent is the same as sine over cosine. This tangent is the same as sine over cosine, and cotangent is cosine over sine. Now here, I'm still kind of stuck, like where do I go from here? I want to get this bottom so that it is one fraction. So I need to get a common denominator on the bottom. So this, we have a cosine and a sine. That means I'm going to multiply this first part by sine over sine. I'm going to multiply the second by cosine over cosine. So then the common denominator there is going to be sine of theta times cosine of theta. Okay, and when we do that, on top we're still left with sine of theta over cosine. From this part, you get sine squared of theta over sine of theta cosine of theta. Here, you get cosine squared of theta and over sine of theta cosine of theta. Okay, any questions to that part? Okay, we can combine this bottom. So since they have the same, that's going to become, the top is still saying sine of theta over cosine. The bottom is sine squared plus cosine squared over sine times cosine. Well, sine squared plus cosine squared is 1, so that we can just change this part to 1. So we have sine of theta over cosine over 1 over sine of theta cosine of theta. Now, since we have like a fraction inside a fraction, like we have this big old fraction mess, let's just write this as division. So I have sine over cosine divided by 1 over sine of theta times cosine of theta. Now, division, you can flip and multiply. Shut up, Bear. You can flip and multiply. So then this becomes sine of theta over cosine times sine of theta cosine of theta over 1. Those cosines cancel. So I'm left with sine of theta times sine of theta, which is sine squared of theta. Now this one was probably one of the way harder ones. Like I don't think I gave you a super hard one like that on the test. But it is good to be able to go through this one, because if you can do this one, you can do the ones that are on the test. Is there questions on that one?
How did you get the 1 on top of the fraction?
So this right here, sine squared of theta plus cosine squared, that is one of our Pythagorean identities, which equals 1. So that's how we went from this to this.
Oh, okay. You just like switch it.
Yeah, so I just used the Pythagorean identity right there.
Okay.
Other questions on this one? Okay, so there's going to be 2 like this on the test. For both of these, write down, this is one where you're going to have to write and then just take a picture of it. You can just use your phone or whatever. Somehow take a picture of it and then just submit it. So that those are ones I'm going to have to grade by hand. Okay? Because I don't know how to make these ones multiple choice. Okay, so then let's get into the sum and difference of angles. So these formulas, have these somewhere handy when you're taking the test. Okay, I don't expect you to like memorize these. I don't even have them memorized. And then I always write all the angles on the unit circle so that it's easier for me to like look at a list and pick which ones work. Okay, and all these questions I'm pretty sure are questions right off of the review. So when you're doing the review, when you get to this question, you can just like pick whatever answer we got to. But so we have cosine of negative 15. Well, negative 15, I know that 45 minus 30 is 15. So if I just reverse that, 30 minus 45 would give me negative 15. So I'm going to use 30 and I'm going to use negative 45. Or just minus 45. So that means I'm using this one right here. Okay, so that's cosine of A times cosine of B plus sine of A times sine of B. So that's going to be cosine of 30 times cosine of 45 plus sine of 30 times sine of 45. So if we look at this, so if you go to 30 degrees, remember cosine is your x value, sine is your y value. So the cosine at 30 degrees, the x value at 30 degrees is square root of 3 over 2. The x value at 45 degrees is square root of 2 over 2. And then the y value at 30 degrees is 1/2. The y value at 45 degrees is square root of 2 over 2. And then we just multiply this out. So square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1 times the square root of 2 is square root of 2. 2 times 2 is 4. Now we can just combine this to be one fraction. So that's going to be square root of 6 plus square root of 2 over 4. Okay, and you can check this. So if you have a calculator, pull it out right now. I'll put it up to the camera, but I don't think you can see it very well. So if you make sure you're in degree mode and you put cosine of negative 15 in your calculator, you get 0.96, blah, 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 something. I'm not even sure if you can see my calculator, but, and then let's put this in the square root of 6 plus square root of 2 over 4. And you should get the same exact thing. So square root of 6 plus square root of 2, 2 over 4. And I get the same exact answer. So it's a way to double check yourself there. Double check that you're getting the same thing. Okay. Questions on that?
And the addition on top can be like flipped, right?
Yes. Yeah. So if it was square root of 2 plus square root of 6, that's completely fine. Okay, let's do this one. So tangent of 13 pi 12ths. I always switch it to degrees. I would just switch this to degrees right now. So do 13 pi 12 times 180 over pi, and you get 195. So we need to find two measures that will add up to give us 195, which I did 60 and 135. You could have done 150 and 45. There's lots of different ones that you could have done. Okay. So then here, this is going to be tangent of 60 plus 135, which means I'm using this right here. So I need to figure out what the tangent of 60 is, what the tangent of 135 is, and that's the only things I need. So it's going to be tangent of 60 plus tangent of 135 over 1 minus tangent of 60 times tangent of 135. So tangent of 60, so tangent is y over x. So the y value at 60 is square root of 3 over 2. The y value, or the x value at 60 is 1/2. Since these are both 2's there, they can just cancel. So I'm left with the square root of 3. And then the tangent of 135, that's right here. So the y value at 135 is square root of 2 over 2. The x value is negative square root of 2 over 2, which same thing on top and bottom with a negative sign means I'm just left with negative 1. Okay. Is there any questions with finding tangent? Okay. So then we can just plug these in. So tangent of 60, that's square root of 3. Tangent of 135, negative 1. Then 1 minus square root of 3 times negative 1, which on top there, that just simplifies to square root of 3 minus 1. On bottom, a negative. So this multiplies to be negative square root of 3. And then a negative minus a negative is a positive. So that's 1 plus the square root of 3. And that is your answer. And you can check yourself here. You could put your calculator in radians and put tangent of 13 pi 12ths. And you should get the same thing as when you put this in. Or if you just want to keep it in degrees, you could do tangent of 195 and you'll get this same exact thing here also. Okay, questions with that one? Okay. So then the double and half angles. So again, have all these somewhere that you can reference them. So let's find the cosine of 13 pi 12ths. So first, change it to degrees. Always change it to degrees. So that's the same as the cosine of 195. Okay, which here, honestly, you could do this the same way that we just did this one. If you wanted to use the sum and difference, you will get the same answer. I'm just going to do it with half angles because it asks to do it with half angles. So let's do this with half angles. So 195, if I double that, that's the same as 390 over 2. Okay, whoops, I need to move this. So 390, that's if we look at our normal unit circle, we have 0 to 360. 390 is obviously bigger than 360. So let's find the angle, the coterminal angle that's between 0 and 360, and you get 30. So that means that the cosine of 390 is the same as the cosine of 30. Okay. And then to determine whether it's positive or negative, I think this is where a lot of people are getting confused. We need to look at the angle we were given to begin with. So we were given this 195. Well, 195 is in the third quadrant. So that means cosine is negative in the third quadrant. So I'm going to use the negative part of this plus or minus. Okay, and I'll show you, there's another time that we do this that you have to like look at the half angle. But in this case, since you're given the angle, you look at where that angle is, and that will determine where you're going to, like where it's going to be positive or negative. So since 195 is in the third quadrant, when we're doing the plus or minus here, it's going to be the positive part of that. I mean, the negative part of that, sorry. So there are questions on that? Okay, so then here, this is going to be negative square root of 1 plus cosine of 390 over 2. Well, we just figured out that the cosine of 390 is the same as the cosine of 30. So that's the square root of 1 plus the cosine of 30 over 2, which if we look at our unit circle, 30 is right here. Cosine is your x value. So that's going to be square root of 3 over 2. And another way you can look at this, like 390, you would just go all the way around the circle. That's 360. You could go up 30 more degrees. That is 390 right there, which is why it's the same thing. So then square root of 3 over 2 is this value. So that's going to be negative square root of 1 plus square root of 3 over 2 over 2. And then we just need to simplify this down. We can't have like fractions inside of fractions. So that's the same as 2 over 2 plus square root of 3 over 2 over 2. We can get this top to be one fraction. So that's going to be 2 plus the square root of 3 over 2. And then that's all divided by 2. Since we have like this double fraction going on, let's just change it to division. So that's going to be 2 plus the square root of 3 over 2 divided by 2, which is the same. You could put this over 1 and flip it. So as multiplying by 1/2. So it's 2 plus the square root of 3 over 2 times 1/2, which is going to be negative 2 plus the square root of 3, because that when you multiply, that's just the same. 2 times 2 is 4. And then anytime you're given, if you have a square root and there is a fraction inside, you can break it up. Like you can square root the top and square root the bottom. So this is the same as negative square root of 2 plus the square root of 3 over the square root of 4. And the square root of 4 is 2. So our final answer here is negative square root of 2 plus the square root of 3. So it's okay to have the square root inside of square root. And then that's over 2. Okay, questions on that?
Yeah, I have a question about the part just before it. So when you have 2 plus square root of 3 over 2 inside of the square root, you can't simplify that and say cancel the 2's 1 plus square root of 3.
No. Because so you could if there was a 2 right here. So if there's a 2 like right in front of the square root of 3, but since this is a sum, you can't like cancel into a sum. It's the same reason why if you had like x plus 3 over x plus 4, you can't cancel those x's.
Okay.
Okay. Any other questions with this? Okay. Let's do this one. So sine of pi halves, find sine of pi halves. If sine is negative 15/17. Oh yeah, I did this one because this was ugly. This is on your review. So when you get to it, we just did it on here. But it's between 7 pi halves and 4 pi. So that is the fourth quadrant. Like technically, so 7 pi halves, if we think about our unit circle. So if you go up 90, that's pi halves, and then pi, and then you go down, that's 3 pi halves, and then 2 pi, and then you go another 90, that's 5 pi halves, and then it would be 3 pi, and then 7 pi halves, and then 4 pi. So that's between that fourth quadrant there. Okay, it's right here. It's basically like we just went around the circle twice. Okay. Questions on that? Okay, so here, first let's determine the sine of this angle. So we need to see where this angle is going to end up. Since they didn't give us like find the sine of whatever, like in the last one they were like find the sine of I don't even remember what it was, but whatever that angle was, we're not given the angle right now. We're given just some ratio and what quadrant it's in. Okay, so we know that this angle is between 630 and 720. If we just convert these back to degrees, so if you do 7 pi over 2 times 180 over pi, you get 630. And 4 pi times 180 over pi is 720. So that's where our angle is. But we're trying to find our half angle. So I'm just going to take half of that. So half of 630 is 315. And half of 720 is 360. So that means our half angle is going to be between 315 and 360, which means the half angle is in the fourth quadrant. And since we're finding sine, cosine is positive in the fourth quadrant, which makes sine negative in the fourth quadrant. So when we do this plus or minus here, we're going to use the negative. Questions on that? Okay. So here we're finding sine of pi halves is negative square root of 1 minus cosine of theta over 2. Well, I know sine of theta, I need to figure out cosine. So if we look at our triangle here, this is where you're going to draw the triangle. Opposite side is negative 15. Hypotenuse is 17. Which makes this side, if you use Pythagorean theorem here, you're going to end up getting 8. Okay. We don't really care about sine because sine's not in here, but we need cosine. So cosine of theta ends up being 8 over 17. Okay, so that's what I'm going to plug in here. So that's going to be negative square root of 1 minus 8/17 over 2. Then we just need to simplify this. So 1 is the same thing as 17 over 17 minus 8 over 17 over 2, which 17 minus 8 is 9, and then over 17 over 2. Same thing here, we have a fraction inside a fraction, so I am just going to change it to division, which dividing by 2 is the same as multiplying by 1/2. So then this is going to be negative 9 over the square root of 34. And just like I did before, if you have a fraction with the square root, we can break it up. So that's going to be square root of 9 over square root of 34, which square root of 9 is 3 over the square root of 34. Then we just have to rationalize it. So multiply by that square root of 34 to top and to bottom. And you get negative 3 square roots of 33. Or 34 over 34. Okay, questions on that one?
So do you have to go and like figure out the angles and the half angles to find that it's in the fourth quadrant, or can you just use the inequality?
Well, it depends. So the only reason this one ended up back in the fourth quadrant was because this had like gone around the circle twice. But say that this was between like 3 pi halves and 2 pi, that would make it between 270 and 360. And if you take half of that, well, half of 270 is like 135. And half of 360 is 180. So that means our half angle would actually be in the second quadrant. So sine would actually be positive and cosine would be negative. So when you're given this, I would always do this right here to determine the half angle. It's not always going to work that like we start in the fourth quadrant. You most of the time won't end in the fourth quadrant. That was only because like this had gone around the circle 2 times. Other questions on this? Okay, so that's the end of this. I didn't do any of these double ones. The double ones are pretty straightforward. You just plug them in and then go through it. For the test tomorrow, if you like, because this is a hard thing, especially it's hard to test online. I really wish that we were doing this in school. If you want to, like, to get partial credit or something, you can send me like your work and I can look through it if you want me to, or like if something happens with the test, please just email me so that we can go through it. But this review is on Canvas. So if you go to Canvas, and I put up the answer key. I just barely did it. Sorry, it took me a minute, but I put up the answer key for day 3. If you just go to modules, it's right here. 11.3 answer key. And then here's the review. I think there's 2 tries on this, and I think I let you see your answer. Yeah, you can. So when you go through this, just do it twice. If you need me to open it for you again, like if you want to use it to study again, you can. You can also print this, which is a kind of nice thing. If you wanted to print it and have it to go over. But that's pretty much it. I'll stay on if you have questions. The test is tomorrow. It will be open from like midnight to midnight. So just do it sometime between that window. You do have 2 hours, so just make sure you like give yourself enough time. Okay. And then that's it. I'm going to stop recording this and I'm going to stop presenting.